Hey everyone, this video is just another step, a couple example problems in our exponent rules practice. At this point, we should all be really familiar with all the different rules. I've gone over those in other videos about multiplying exponents with the same base, dividing exponents with the same base, raising a power to a power. What happens when I have 0 as an exponent? What happens if I have a negative exponent? If you're unfamiliar with those things, I encourage you to go back to prior videos or follow up with me, because at this point, I'm assuming you know all the rules, and now we're just putting them all together. So the way that we do that is in this specific order. So we want to start with raising a power to a power. We want to use the exponent. Then we want to multiply or divide. Remember, those exponents need to have the same base in order to do that. And then at the end, we're going to deal with 0 and negative exponents. So if you don't have that list down, please write it down now, because we're going to do some practice problems that follow those steps. Let's start with this one right here. I've got 2x over 3y to the fifth, all raised to the second power. So we always want to start with raising a power to a power. And just like in the last video, we are going to basically distribute this exponent to what's inside the parentheses. But now I have a lot more terms to deal with, and that's okay. We're going to raise 2 to the second power, x to the second power, 3 to the second power, and y to the fifth to the second power. So let's see what that looks like. So I'm basically distributing the 2 to everything inside the parentheses. In this particular problem, there's 4 different terms, 1, 2, 3, 4. And we just got to keep track of our rules as to what that's going to look like. So it's going to stay in fraction form. So this is going to be 2 to the second power, x raised to the second power. Remember, there's a 1 here as the exponent of x. So when I raise a power to a power, I multiply. So 1 times 2 is 2. So it's going to be x to the second power. 3 to the second power, moving into the denominator there. And then y to the fifth is going to turn into y to the 10th, because 5 times 2 is 10. Now, if x and y are the same base, I could simplify that a little further, but I can't. They're different exponents with different bases. What I can do is raise this 2 to the second power, which is 4, and 3 to the second power, which is 9. And the x and y terms stay the same. And that is my simplified version of that problem. Okay, because I can't multiply, I can't divide, and I didn't have any negative exponents to deal with. So that's the first step here. Let's go on to the second one. Again, I've got terms inside my parentheses that are all raised to the -3 power. I do the same thing. I'm going to distribute that -3 as an exponent to all the terms inside. This one's going to look, we've got a couple more steps to do here. So again, the 6 is going to be raised to the -3. N to the second power, well, all I need to do is multiply my exponents. 2 times -3 is -6. So this becomes n to the -6th power, 3 to the -3 power, and n, there's a 1 there. I can do 1 times -3. My exponents become -3. Okay, let's see if we can multiply or divide. I see that my n's have the same base here, so I can simplify these exponents by subtracting. So this is going to become, this is where you got to keep track of your numerator and denominator. So 6 to the -3, nothing's going to happen here. N is going to turn into -6 minus -3. So again, that's my rule when I'm dividing exponents. I just subtract. I took the -6 and I subtracted from a -3. We're going to clean this up in a moment. And let's just do the other term, 3 to -3 power. This -6 is going to turn into a +3. This is a double negative. So my new exponent for the n term, I'm going to do things one at a time here, is -3. -6 plus +3, I'm cleaning this up, is a -3. And then 3 to the -3 power again. I'm rewriting a lot of things because I like to deal with my negative exponents at the very end, which is going to be my next step here. Remember, my rule when I'm dealing with negative exponents is it gets flipped into the denominator. So this 6 is going to fall down to the denominator. So is this n. But what's going to happen to this 3 to the -3? Well, if I already have a term in my denominator and that term has a negative exponent, that is going to get flipped up to the numerator. So really all negative exponents do is they just turn it on its head. If it's in the numerator, it drops down to the denominator. If it's in the denominator, it goes up to the numerator. So this problem, start with the numerator. So the 3 to the 3rd power is going to be in the numerator. The 6 to the 3rd power is going to drop down in the denominator. So is the n to the 3rd power. Notice that when my exponents move, they go from negative to positive. I can clean this up a little bit further. 3 to the 3rd power, that's 27. 3 times 3 is 9, times 3 is 27. 6 to the 3rd power is 216. And then n to the 3rd, we can't do anything with that. So that's my final answer for that particular problem. Cool. That's all I got. Thanks for watching.